Afternoon, and welcome to our summer weather outlook. My name is Andrea Berg, and I am your host today for our webinar. If I just have a few housekeeping items that I'd like to go through. Everybody is on mute, so if you have any questions, please use the Q&A feature on the right-hand side of your screen, and we will answer your questions throughout the presentation. Also, we are recording this session, so if you miss anything or want to share this webinar with any of your colleagues, you will receive the recording and a report about a few days after this webinar. So with that, I would like to turn the presentation over to Stephen Davenport. Stephen?
Hello, everybody. I'm Stephen Davenport, weather risk analyst at DTN. Here's some of the topics we're going to be looking through today, highlights of the UK's summer last year, the expected seasonal influences, analogues for 2022 and the seasonal model forecasts, and then our official summer season outlook from DTN. And following that, we'll have a panel discussion. And any questions? So firstly, look at what we saw in summer 2021, what that gave us, and starting with the temperatures. On the whole, as you can see from the graphic on the left here, it was warmer than average across much of the UK for the 3 summer months. If we break it down month by month on the right there, June and July saw the bulk of the warmth, while August was cooler than normal, at least over the south of England and parts of Wales, along with much of Northern Europe. Zooming in on the UK, we can see that better, above normal pretty much everywhere through June and July, just near normal locally. But then we can see those cool anomalies across the southern UK during August. As far as rainfall was concerned, a bit of a north-south split, with Scotland and Northern Ireland drier than normal through the summer, but the south and east of England wetter. During June, much of the country was drier than normal, but the southeast was wetter, with some heavy rains edging northwards from the continent at times, some thundering outbreaks as well. July stayed drier than normal in the northwest, still wetter in the south and some central and eastern parts. Then August was a little drier than normal. That shows a lot better here on the more detailed analysis. We had about 75%, 73 to 75% of normal rainfall. In June, the wet weather manifested as occasional outbreaks of heavy thundery rain through to mid-month. One or two power cuts in the southeast, along with some flooding, fallen trees. Then late month, another thundery outbreak affected parts of Wales, the Midlands and the southeast again, with a couple of weak tornadoes reported in the southeast, and Barking, for example, damaged a few houses. There was one named storm from the UK Met Office. There was Storm Everett in July, the first named storm to have occurred in July. Greatest impacts, though, were on, well, mostly holidaymakers and residents in the south. Copious amounts of rain, unusually strong winds for July, mainly in the southwest, gusts of 40 to 60 miles an hour, and very rapid accumulations of 40 to 50 millimeters of rain. First part of July had numerous thunderstorms, heavy rain, local flooding. Didn't have too much significant impacts on infrastructures. Then there were some hot spells through mid-July, which is when Northern Ireland had its highest temperature on record. Castle Derg in County Tyrone rose to 31.3 Celsius. That led to extreme pressure on Northern Ireland waters network. Then late month, there were further bouts of thunderstorms and heavy rain with a few power outages, mainly for Scotland, southeast England. Those conditions lingered into early August, with further flooding in places, occasional strong winds, but then high pressure settled the weather down from about mid-month. Quick look at conditions across Europe as well last year. It was warm, temperatures a degree above normal for the summer, similar to 2010 and 2018, but August cooled down somewhat in northern regions of Europe, while in the south and around the Med, there was a heat wave from July into August, helped to cause wildfires around the eastern Med. I mentioned some heavy rains and thunderstorms during July, and around 13th to 15th of July, there were floods in Central Europe with 2 months worth of rain falling in just 3 days. Those stronger winds we had at times in the summer of 2021 were very localized and sporadic, mostly associated with those bouts of heavy thundery rain with a lack of sustained wind strength. With an eye on renewables, wind speeds for that summer were well below average for the UK, the lowest in 60 years. SSE reported 32% less power production than expected, which of course impacted energy prices. The Atlantic tropical / hurricane season was very active, the third most active on record, with 21 named storms, 7 hurricanes, 4 major hurricanes, with another early start before the official beginning of the season, June 1st. So we're seeing hurricanes forming before that last year. This year is a slower start, but the forecasters will see is for another active season. Perhaps surprisingly, given that enhanced activity, none of those storms last summer had their remnants directly affecting the UK. Now, 2022 has similar climate drivers, like we have La Nina in the Pacific, so we'll see later if we're expecting a similar year. Now look at the spring just gone. Most places it was a little warmer than average through all 3 months, March through May. Notwithstanding periodic thundery outbreaks, it was also drier than average, or at least near average. But then west to southwesterly flows brought a lot more rain to northern and western Scotland in April and May, to a lesser extent to Northern Ireland as well. Now on to this summer's forecast. What are the main seasonal drivers then? The teleconnections. These are the large-scale atmospheric oceanic influences on the northern hemispheric weather. We currently have in place a weak La Nina, similar to 21, a little bit weaker than that. We expect that to continue through the summer. As visible here is a band of cooler than normal seas in the equatorial Pacific, extending west from northern South America. Latest forecast suggests some weakening of that, tending towards neutral for a while, but that's not too unusual through the early to mid-summer, and it's not expected to strengthen significantly. The PDO state should help keep La Nina going, even if it's weak. And we're in the negative phase of the PDO. That's manifests as a horseshoe of cool water just off the western coast of North America, surrounding a large area of anomalous warmth in the North Pacific, extending all the way westwards to Japan. PDO is an important driver of North American conditions in particular, for example, in conjunction with a positive AMO, that's the warm Atlantic. The southwestern US tends to be dry, but it also affects European conditions despite being so far away. It's just a long-lasting feature. We're currently into the 7th year of the negative phase. It tends to promote high pressure near Greenland, lower pressure over northern Europe. Thirdly, the AMO, a significant factor. We're in a positive phase with warmer than normal conditions in the Atlantic basin, and we're expecting it to warm further through the summer, and that should assist the chances of generally warmer than normal conditions in Western Europe and contribute to an active hurricane season. So here's the ENSO forecast, which you can see from the model averages is weekly negative, or in a weak La Nina state from early to mid-summer, with a bit of resurgence, a drop in temperatures later summer and into August. Not unusual. La Ninas tend to develop in autumn and winter, weaken somewhat in summer, then repeat in year 2, which is where we are. So you can see up until November, there are no models suggesting any move towards El Nino conditions. So looks like we're in for a La Nina summer, albeit potentially a fairly weak one. So let's look at the analogues. It's the average weather conditions from previous years with similar patterns that we're expecting for this year. So we have La Nina, the PDO, the AMO, other drivers like the QBO and the Indian Ocean dipole. Currently negative, the dipole, which can promote low pressure near Western Europe. And we add to that some forecast adjustment depending on the pattern behaved during those years. So here are the weighted temperature analogues. First thing I would say is be careful with taking the average at face value. A few very cool years can skew the average downwards, and that's what we're seeing here. We have a couple of cool years amongst our analogues which are skewing it. So probability here is more useful if you like to look at it. So we can see that it's more probable that the 3 months of summer will be warmer than average. Similarly, for rainfall, the analog average suggests near normal precipitation, while the probability is indicative of drier than normal conditions across the southern half of the UK, for much of Ireland, Northern Ireland, and a hint of wetter conditions for northern parts of the UK, particularly over Scotland. But in general, probability view favouring a drier summer. Second tool is our seasonal models, chiefly from the American CFS V2 model and the European model at ECMWF, which both simulate large-scale seasonal outlooks. So here are the CFS V2 outlooks, temperatures on the left, precipitation on the right, indicating for the UK and Ireland warmer than average conditions each month, June, July and August, and drier than normal during June. The ECMWF is similar for June and August, with above average temperatures projected, but near normal in July. The last couple of runs of this model, July has trended cooler and also wetter, as we can see in the precipitation outlook here on the right. This is much wetter than previous runs, so there's some uncertainty with that kind of volatility. For June, though, it looks dry in the north, wet in the south, then wetter than average for the northern UK in August. So the forecast is compiled with all these sources in mind. We look at climatology, narrow that down to the trends over the past decade, then relate this to the statistical analogues from the teleconnections and some of the seasonal computer models to create our final forecast solution. So on to the highlights of DTN's forecast itself. The broad pattern expected for the summer favours high pressure developing to the west or northwest of the UK during June and July, which is driving those expectations of drier than normal conditions, although with lower confidence, as we've seen during July. During August, we expect low pressure to become more dominant across the UK and Scandinavia. You can see the pressure anomalies there. So that naturally increases rainfall chances. There are some risks of this slipping forward into July and bring that wetter risk. What impact is that pattern going to have on temperatures? Well, temperatures expected to be above normal through each month of summer. You can see the official DTN temperature outlook for the summer. Temperatures widely above normal, the forecast for the 3 summer months. June, perhaps the most anomalously warm. July has less confidence, could trend cooler given the wetter risks. Having said that, it's more likely than not for the summer as a whole, the temperatures are going to be above average, or at worst near normal But a cooler July would mean that the positive anomaly would be rather small. Long-term trends also make a warmer than normal summer more likely, and lower than average soil moisture conditions across large parts of Central Europe also increase the chances for warmer than normal temperatures even more. So overall, the forecast trended a little cooler in our latest update across north central parts of Europe, but still above normal. With heat already having built over South and Southwest Europe as well, after we've seen some very high, even record-breaking temperatures around the Iberian Peninsula, the proximity of any low pressure systems could deliver short spikes in temperature, strong spikes in temperature associated with plumes from the continent, which could also be thundery. With that high pressure dominance, a drier than normal summer is expected, but with the proviso that July confidence is lower and has a risk of seeing average precipitation amounts or even greater. Nevertheless, the summer as a whole would still be expected to have at least slight dry anomalies. With the forecast calling for low pressure tracks to develop during August across the UK, that month will probably become wetter across northern and western regions, especially Scotland, Northern Ireland, the Republic of Ireland, and particularly if we see any hurricane remnants move through. Speaking of which, a look at the tropics now. Like 2021, a very active tropical season is expected, thanks to two main reasons. That's warmer than average water in the Gulf of Mexico and the North Atlantic, and relatively low vertical wind shear in the southern North Atlantic and the Caribbean. That's a low change in wind strength and direction with height. Strong wind shear tends to disrupt hurricane development. La Nina or neutral ENSO conditions are also favorable for enhanced tropical development, and the expected low wind shear, warm Atlantic and Caribbean through the heart of the season are all indicative of a very active season. One in which one might reasonably expect to see the remnants of one or two storms affecting the UK and Ireland, despite what happened, or rather didn't happen last year. If that were to happen, there would be risks of periods of heavy rain and strong winds that are masked in the broad seasonal pattern forecasts. Seasonal forecasts like that can't pick out individual storms. Ex-Hurricane Ophelia is an example there to 2017, which was the most easterly forming hurricane on record formed near the Azores, and that brought copious rain and strong winds to the UK and Ireland, the worst storm to hit Ireland in about 50 years. In the short range, we've got our ex-Hurricane Alexa heading northeast across the Atlantic, passing between Scotland and Ireland. So we're seeing wet and windy weather developing, especially across the northern and western UK for the next few days. That's also going to force the Azores high to extend into Central Europe, bringing some sunny summer-like weather as we go into next week. Aside from that, the DTN forecast calls for 21 named storms, 8 hurricanes, 4 major hurricanes, similar to last year. Average from the Analogue year, 17 or 18 named storms we're expecting, a little on the upper side of that. Now for renewables, how are wind and solar looking for this summer? Well, we've already seen that last summer was very poor for wind production, but what can we expect this year? Well, shouldn't be as bad, with near normal to above average wind speeds expected for the summer as a whole. Given the expected pressure pattern, the best anomalies look to be over the northern UK, the best winds up that way. At the moment, July is expected to be quieter, but recall the risks to the forecast with potential for low pressure development to shift forwards from August. So risk is on the side of greater production than we are showing here, or greater wind speeds than we are showing. That, of course, would also have consequences on solar production. July at the moment is forecast to have above average solar, but the risk is for wetter and cloudier conditions to develop. Either side, June is forecast to be near or a little above average, and August, with its forecast unsettled conditions, should be a cloudier month with near or below normal solar. For the summer as a whole, then, that makes it a bit of a wash with near average solar, most likely. So in summary, the key messages are these, with that proviso about July. Most likely warmer than normal through the summer with near average rainfall. August most likely to be the wettest of the 3 months. Another very active tropical season in the Atlantic with chances of post-tropical storms reaching the UK. And these can be disruptive to short to medium range forecasts. And that is your summer outlook. I'll open it up to any questions and discussion.
So if anybody has any questions, please use the Q&A feature on the right-hand side of your screen. So seeing no questions, I think we should move forward into our panel discussion, which is preparing and planning for this summer's weather. So I'd like to introduce our panelists, Brad Nelson, Dominic Hallett, and Rob Hutchinson.
All right. Hello, everyone. Good to be on the call and talk to you a little more of an open discussion on the summer outlook and get our range of experts on here that can, discuss kind of the weather mitigation risks that our customers, our partners, businesses rely on with DTN, and then some of the general impacts that we can expect for the UK, Ireland, Scotland as we head into the summer, based on what you have just heard regarding the summer outlook here. So we do have a range of different sectors on the call, many industries. So we're going to take a holistic approach to this discussion on the weather risk management part. So with that, the first question that I have, it does appear favorable for above, we're going to focus on temperatures first, above average temperatures through the UK. And in particular, something, Stephen, that you mentioned, I'll have you touch on this first, the strong spikes in temperatures that can occur with some of these heat waves. What is your thoughts on implications for the various industries like utilities, events, public safety, power generation, aviation, in particular to the above normal temperatures that are expected, and also those temperature spikes, what kind of impacts they have on the industries? I think you're muted there, Stephen.
Yeah, to start with, we can see effects on infrastructures such as risks of sagging power lines during summer during those heat spikes. The heat, as I mentioned, is often accompanied by fairly strong outbreaks of thunderstorms moving up from the continent as well. So lightning, it's a secondary risk there. I guess for things like roads, looking at risks to the road surfaces and so forth. But yeah, maybe I can bring Rob in on this as well.
Sure. Yeah. I mean, with that kind of that build-up of heat, especially across Europe, it's always puts us more at risk of heat migrating north in these Spanish plume type events. So, yeah, that can bring short-lived but intense heat waves with the attendant weather risks. So, putting myself in our utility client shoes a little bit, one concern there is, you know, threats to their assets. You mentioned power lines sagging, that can bring the risk of faults, but also thunderstorms as well. If with these type of plume events, you can get tens of thousands or even hundreds of thousands of lightning strikes, which puts the could cause trips and faults on the usually the distribution network, but occasionally also the transmission network. The Southeast saw a very large fault on the transmission network a couple of years ago, caused by lightning, which resulted in several million customers without power. And I think it's also a good question to ask Dom as well from Southern Water on the call. I mean, how do these kind of thunderstorms tend to impact typical water utility? You know, you've got some interesting kind of stories from that perspective, Dom.
I do. Hopefully, I'm coming through.
Loud and clear.
Fantastic. Yeah, so I guess start with the temperature element, the heat. Short-term spikes from a water sector perspective, not usually too much of a long-term impact, but the short-term impact is around usage and our distribution, our ability to meet supply and demand essentially increases. So we need to make sure that the recovery element from a longer and mid-term strategy is there. Obviously, we can't control that. Literally can't control the weather. So from our perspective as a water company and a water sector, recovery, storage, and the ability to increase our distribution output is something that we're really going to be paying attention to for the short-term spikes. Being where I am physically, I'm on the south coast of the UK. We've got a really long coastline. We cover most of the southeast, and it's a very desirable place to go from a holiday and tourist destination perspective. So we do see that input increase. From a thunderstorm perspective, I get chills, I get goosebumps, I get very nervous. So as Rob really articulately put, it interrupts our power supply and our power interruptions. And essentially it creates a significant issue, both from a water abstraction and production perspective, but also from a wastewater treatment and recycling perspective. So the ability to put water back into the environment in a really good treated quality becomes compromised. So it affects all branches of our operation and poses a risk both to customers and to the environment, which is a key one for us. And I can talk to you about the impacts or the stuff. And I think we're going to get onto that in a little bit.
Yeah, on that note too, Dominic, I was wondering, you know, with the, you know, the warmer conditions, these spikes in temp, but also you have to take the rainfall forecast into account. So we're starting off, looks like drier early summer, and then maybe the second half of the summer we end up wetter. So how do you prepare for that, for those fluctuations in rainfall as well in correlation with the warmer temperatures?
I have the blessed position of seeing this insight. That's point number one, I guess. So the fact that we've got indications of certain weather types enables us to make certain proactive changes to our asset maintenance programs, to our resourcing models, to look at how we can shape that up. And from a Southern Water perspective, we have a number of sort of data inputs from DTN, which is really useful for us. We have this seasonal output, so we can see the next 3 months. We've got that early indicator. We've got the ability to dwell on the other forecast ranges, the sub-seasonal, which gives us that twice a week view of the next 3 weeks. So the confidence level likely increases, and then we've got the ability to drive that daily forecast, which we get, and that provides us with a 10-day outlook. Essentially what we do is use that information to drive where our reaction is going to be, where the preparedness is going to be, whether we need to establish certain folks to work extended hours or within a different working operating window, whether we need to get mitigations through alternate power supplies, alternate mechanisms to remove water or wastewater from pipes, and it allows us to proactively go and do that. So that's the benefit from Southern Water's perspective on that.
Yeah, and you mentioned some of the day-to-day weather mitigation risks as well. So I know you're a Weather Century Online user as well. So what do you typically monitor on a day-to-day basis? Are you looking at primarily the thunderstorm activity, some heavy rainfall events, high winds? I mean, you name it. I mean, you can all monitor that through there and be alerted for that. So how do you use the DTN solutions in your day-to-day operations as well?
Weather Sentry was a fascinating bit of software, if I'm completely honest with you, Brad. So this ended up coming about from conversations with Rob last year. As you can see from the forecast last year and what occurred down in the south coast, we did get a lot of tropical impact. We had quite a wet summer, with some quick storms coming. One particular site of ours, unfortunately, it's a well-known one from a reputational impact perspective, and it is situated on the very northeast coast of our operating area, at Foreness Point in Margate. And one particular evening, we knew we had thunderstorms coming based on the forecast information, and the risk was there. And I think based on what actually occurred on the night, a lightning strike hit that station. Within 6 minutes, we had escalation from the site to our central control room, and we had an incident team managing the event and response. Now, what that led to was a conversation between Rob and I, that said, how do I get better visibility of lightning activity? Because we just didn't have it. And cue Weather Sentry. So what we have been able to do since is establish key areas within our operation. We've been able to establish sort of risk parameters through concentric circles and lightning strikes, and we've got the ability to just watch that happen where there is a risk of lightning and thunderstorm activity occurring in the atmosphere. So it makes my life so much easier to see this stuff happening and playing out as it's going on, because the response moves and changes so quickly with lightning. It's so it either goes through the operating area with zero impact, or it can have the absolute most impact, and it's just dependent on where that strike is. But we're able to quantify where that strike is now, and we can use that to provide information to our customers, to our regulators, to stand up a response to drive a different set of actions that is all in aid and in spirit of protecting our environment and our customers. That's exactly how we use it. And I guess the most prevalent use of it was very recently through Storm Eunice in the UK, where we had some really significant high winds. I think the greatest speed in our operating area was on the Isle of Wight. I think we reached speeds of about 122 miles an hour, something like that. Significant power interruptions, and the Weather Sentry application for me, it was live about 24 to 40. I mean, it's up there all the time, but it was really front and center for the 24, 48 hours prior. We had driven a load of of proactive work of coordination of incident management response teams, various other folks, and essentially what we were able to do is come through this with little to no impact to our customers and to our environment. And one feature that flagged something really quickly in that particular event was essentially the weather warning status that came through from the Met Office. We had the red of our region, so the red warning pop up across the southeast coast, I think about an hour before we received an email notification from the Met Office to say it's gone from amber to red. So Weather Sentry for us provided us with all of the right information, all of the timely information, and allowed us to prepare.
Yeah, I
Tom,
think
just
that's
expanding. Oh, sorry, Brad. Can I ask Tom to expand a little bit on that? By, I know working with you guys for many years, right? You've gone from probably, it's fair to say, quite a reactive stance to a lot more proactive stance. I wonder if you kind of expand a little bit about what that means for Southern Water and being able to, basically bottom line really, and the reputation with regulators and customers and so on, what the kind of spin-offs are, if you like.
Yeah, so the I guess it started maybe 4 to 5 years ago, really. The evolution of weather data and information coming into us, certainly from DTN. We had made use of one product, I think, at the time, and had the ability to get access to information. and 2018 landed it for us. That really cold event, I don't know if anyone remembers it, the Beast from the East, that little thing. It had a huge impact, and our resilience as an organization was heavily criticized by the regulator in their sort of central report against the water company performance. And it changed rightly the attitude and response that we need to have when it comes to preparedness, especially when there is that access to information. We've gone from that reactive, Rob, as you said, the journey that we went on went from looking at a precipitation radar to having holistic situational awareness that's feeding into a number of different sources and different systems at this point. But essentially what I've got is a 2-week to 3-week outlook that's preceded by this 3-monthly one. And I've then got my on-day responders looking at and assessing what the next 48 to 72 hours looks like to drive immediate action. I've got the ability to mobilize new people and establish 24-hour coverage in almost every single part of my organization, whether that's operational response, customer response, alternative mitigations. And what we have got is confidence, I guess, from our regulator now that says we can see the response, and that was evident again of Storm Eunice to say how well we have responded. Some of our neighbouring colleagues at other water companies fared a little bit worse than we did. I think that's safe to say. And a lot of it, I think, comes down to the ability to utilise the information that's coming in, have a set of actions that come on the back of it through weather preparedness and adverse weather frameworks, and then drive a response. And it's all through the data that's coming through. And yeah, we probably wouldn't have been as people refer to, and I don't know if this is the same for other folks that are on this call. There's a phrase that gets used a lot, which is we get lucky. We were lucky that it didn't do this, or we were lucky that this didn't happen. And I've started challenging that behavior in my organization, certainly, to go, we weren't lucky. We had data, we had information, and what we did is acted with that information, and to put the best possible response in place, we prevented what could have happened. So this is not luck, this is good planning, this is good preparedness, and the change in the environment, it just feels so much different and so much better and calmer, which is very strange. A control room calm in adverse weather is a very strange place to be, but we're getting there.
Safe to say that you guys put an enormous amount of work into developing that kind of robust set of procedures and plans that are kind of triggered by the data that's coming into you. Certainly been it's been a bit of a journey over the last 5-10 years or so, definitely. I just want, there's a kind of side comment as well. I mean, there's all of these data and decision-making tools, but I think sometimes, the ability to kind of speak and interact with the meteorologists can kind of give you some additional confidence, might be the word. I'm just wondering how if you could kind of expand how, you see the kind of relationship between the kind of decision support meteorologists and yourselves and how that works at Southern Water.
Confidence is the most choice word you could have used there, Rob, because the thing that we don't want to do and what we can't afford to do is move people from, say, the core hour working to the nighttime working, or request that additional resource. We can't do it every single day or every single chance that there's a bit of an added level of precipitation or something that might cause a risk, because often than not, the confidence changes. The closer you get to it, the more confident we tend to become. And that's evident from what I've seen. The conversations that we have with those meteorologists, so my control room duty managers, at the point of seeing that sort of volumetric precipitation or storm event or wind or whatever it may be, whichever weather type is causing us that potential for concern, prompts that telephone conversation. We establish the way in which it's going to move across our operating area. So is it moving from east to west? That's going to help our resource models. Is it moving from south to north? Where is the likelihood of heavier downpours if that can be ascertained, and sometimes it can, depending on the models that are available. But the fact that we can talk about it means that we've got that added level of information to respond and prepare to. So it all aids us in that decision making process, that stand up process, and the ability to act on it. So it's worthwhile. It's all about confidence, Rob, for sure.
Yeah, that's good. That's a good point. I think it's important to bring that human factor into the loop, as far as our risk communicator meteorologists, that, you know, they can give you a forecast, you know, and you need to kind of dissect on what does this mean for me. But if they understand your operations and what decision points you're making based on the weather, they can kind of give you that extra level of support. Like, all right, you know, a weather system's coming, but what does this actually mean for my infrastructure? You know, what decisions do I need to make? And they can communicate those risks to you.
You're absolutely right, Brad. Some weather types don't have an impact on half of my operation. So
Exactly.
primarily precipitation. So rainfall, as one example, doesn't hugely impact my water production. It doesn't hugely impact my water networks. It's going to significantly impact my wastewater networks and my wastewater treatment capacity, because we have, in the water sector, we've got a challenge with combined sewers. It's a nationwide problem. Environmental impact, it's a really hot topic, for all the right reasons. It's all about protecting the environment that we're living in. So yeah, those conversations are super critical, and we employ them as much as we can. We've got the ability 24 hours a day to use that service. So it's one that we absolutely drive.
Dom, what do you see the next 5-10 years? You know, what do you see the future holds in store in terms of weather analytics, but then also changing threat landscape for water utilities as climate change unfolds, and you know, there's pressures with increasing population density and so on? What do you think that means
So
for you?
it's a huge one, that, isn't it, Rob? How long have we got left? There's a number of items that come with this. So the southeast certainly is in, I mean, even not even from a weather perspective right now. Let's look at just population increase. The amount of housing that is being built, the amount of connections that are being built. We're building properties on floodplains or below the water table, so there's flooding risks. There's a huge amount of risk there with the slightest bit of precipitation and rainfall, as opposed to what we would traditionally deal with as an event or a weather event. So we need to be really keen to that. The southeast is a real water stress area from an abstraction perspective. So getting water out of the environment safely without impacting the local environment itself, we're getting really tight permits and restrictions from regulators like the Environmental Agency. It's for the right reasons. It's to protect some of this wonderful, beautiful natural environment that we've got. It makes our job as a wholesale water provider very difficult. But we've got to come up with new ways. So being able to use things like the soil moisture information, things like the likelihood of a drier or warmer summer, enables us to plan a little bit more longer term around what our water production and abstraction strategies are going to look like. It helps us inform what our asset base needs to look like. It helps us with more strategic decisions around innovation. So do we need to look at bulk imports from another organization? Do we need to look at other methods of abstracting that water and recycling some water that's coming out of our wastewater treatment works, which is a huge educational piece. It's one that's happening in the west of our region, over in Hampshire, as a collaborative venture with Portsmouth Water, and is a huge joined up way of creating this interlinking water network to make sure that we have got, I mean, our brand is water for life. That's what we're trying to do. We're trying to ensure that people have got water, not just humans, but the animals and various other things in the environment we have. So the changes over the next 5 years, climate change, crikey. That's a big old challenge. it's a real challenge, and rightly so. You know, as we progress as well, regulations and performance objectives from our regulator get tighter, expectations from our customers get harsher, um, and that's just with the evolution of technology and various other services. Um, the ability to use weather data with our alarm management systems, the ability to interact and make sure that we can make as much automated decisions based on observed rainfall and things like that is going to be sort of the way forward. I know there are huge amounts of technological advances taking place, not just in the UK, but certainly over in Europe, that are all adding to the pressures that are the utility, not just the water sector.
Yeah, and since we're on oh, go ahead, Rob.
Sorry about cutting again. I was going to ask, I mean, you know, we see a big trend across various sectors, being the fact that kind of machine learning techniques have kind of really opened up the possibility to forecast not just the weather, right, but linking the weather with historical data, whether that be alarm data or if you power DNO, historical fault data, but marrying up that data to actually start thinking about forecasting the impacts, how many alarms are going to be, how many power outages they're going to be, where are they going to be. Do you see that in the roadmap for Southern Water as well?
I would love to say yes. I would love to say yes. The ability to make our folks' decision making as simple and easy and as informed as possible is route one. It's got to be route one. How we get there from the data maturity perspective, cool, that's a tough one. I'll let our IT department answer that one another day. But the intention and the desire from our central control is absolutely around the ability to have as much machine learning as possible, the ability to draw on historical impact with observed right now weather data is one indicator and one factor that's going to be hugely beneficial. It informs our decision and our response. So there's absolutely a desire from our perspective to get that progressed over however long.
On the note of climate change, I kind of want to bring in Stephen here about, you know, what have you seen in regards to the trends in temperature, precipitation, and other things like, you know, tropical activity, you know, these storms reaching the UK, and also, is there any correlation in increased lightning activity as well? Like, what are you seeing, you know, in your expertise on kind of the trends that we've, you know, with climate change recently? I think you're muted there, Stephen.
I'm so sorry, I'm really bad at the mute button. Yeah, the trend, as you say, is towards warmer, and also wetter, with more warmth in the oceans and the atmosphere. It's greater evaporation, more moisture available for heavy rainfall events. So I think we're seeing probably an increase in those kinds of events in this part of the world. In fact, in many parts of the world, along with the increased temperatures. Likelihood also is for more active, all other things being equal, more active hurricane seasons and threats. Although we saw, you know, none of those remnants coming across last year, one would expect there to be greater chances of hurricane remnants, given the increased frequency that we can expect in a warming world to be reaching northwestern parts of Europe, and bringing the impacts that we're all very aware of. As for the lightning question, again, with greater heat, greater fuel, that perhaps they're maybe not seen a trend yet, but the trend could be towards greater threats of severe outbreaks for the UK. Actually, if we can just loop back, it raises a question of how predictable lightning can be in the long range. It's a difficult thing to pin down at seasonal ranges. So, this year, will there be more lightning, more thunderstorm activity than usual, or more disruptive events than usual? It may be obvious to say, but during the summer month, especially with warmer than normal conditions like we're expecting, any unsettled conditions come with a relatively high risk of thunderstorms. There's also been a study I saw from a few years ago suggests greater risks of lightning during La Nina, although that's more southerly latitude, south of about 35 north. That study was done. So it's maybe not. It's harder to apply to more temperate latitudes. We might assume that greater rain amounts means greater thunderstorm chance, like with extratropical storms, is localized outbreaks of heavy thundery rain are masked at the month-to-month level by the rainfall indicated by the broad pattern. There are some indications of potential outbreaks and mesoscale convective systems from the pressure pattern we're expecting that could be supporting troughs moving north out of the continent. And we're also more likely to see the thundery outbreaks when there's a lot of moisture through the atmosphere coinciding with elevated jet stream winds, so stronger jet stream winds than normal overhead. And some of the analogues for summer are suggesting just that kind of setup. Moist atmosphere, stronger than normal jet at times across the southern UK. So perhaps we can suggest maybe a greater possibility of somewhat enhanced thunderstorm and lightning risks across the south rather than the north.
Sounds like I've got some work to do this summer, Stephen. Thank you for that one.
Potentially, it's tenuous, but it's certainly a risk. Yeah.
I think that shows the importance, really, of businesses like Southern Water and many other industries in the region to not only be proactive on the short term, the days 1 through 3, weather that's coming into your area, and also the long range, but you really need to be looking, like we've already talked about, your vision, your plan for 5 to 10 years down the road. What's going to happen to the climate? What are the changes we can expect? And then you can get ahead of it, Dominic, and make those plans so that you're not, again, like reacting to a changing weather climate situation. You're already prepared for what is most likely to come here. So great. Well, that's all the questions I have. Anybody else have any topics they want to speak on? I think we covered quite a bit today. A lot that can be, basically applied to not only the energy and utility industries, but numerous industries across the board. So, like we mentioned, taking that holistic approach to weather risk management is extremely important. So, I want to thank Stephen. Excellent job on the outlook. Great presentation. Really appreciate it. Rob, thanks to you for being part of the call and adding your expert insight. And then, Dominic, you as well. You're a valued, trusted partner. We have a great relationship, so we really appreciate, your real in-depth insights into, how weather impacts your operations, how you really manage the weather risks. So, with that, I believe we can end the panel discussion today. So, appreciate everyone for joining.